All right, what we're starting here is our geometry 1 through 40 review. We're going to cover some questions off the review. Some of this stuff is on the test, so you want to take good notes while we're going through this. Our most missed question, or at least among our most missed questions, starts off with number 5, which is a question a lot of people ask me about while they were working on their review. One of the things you want to be careful about here is that it says find BD, so make sure that you're identifying what it is that you actually need to end up with. Okay, so there's a couple different ways to solve this, but if you remember this, if going back from your notes, is that this is to this as this is to this. The other way of looking at it is this is to this as this is to this. So there's a couple of different things that we can do, but ultimately what we want to do is we want to set up a proportion. Okay, so if I start with the first one, right, that would be 18 over 3x minus 3 is equal to 15 over x plus 5. How many of us were able to set it up that way or something similar to that? Nobody. Okay, nobody set it up. Did anybody set it up kind of what you would see the red path? No. Okay. All right, so we're going to use this to solve for x. Once I solve for x, what should I do? Plug it back in, but just anywhere? To 3x minus 3. Okay, so now that I've got a proportion set up, so far does this make sense? Okay, how do I go about solving a proportion? Cross multiply. Okay, tell me what you mean by cross multiply. What am I multiplying? Okay, so this. Now, we still have to be careful with this because you said we're going to multiply 15 times 3x minus 3. Can you tell me what that's actually going to look like after I've multiplied it? What's 15 times 3x? 3x times 15? Yeah, what is that though? I mean, I can write it down here, 15 times 3x. Am I just multiplying the 15 times the 3x, or am I also multiplying it by the negative 3? By the negative 3 as well. So I could draw it up like this and show that distribution taking place. Okay, what is 15 times 3 though? So I should get 45x minus 45, right? Okay, and on the other side, what do I have? 18 times x plus 5. Okay, good. And I'm going to do what there? Distribute. Okay, so 18 times x is 18x. 18 times 5 is, was it 90? 90. Okay. Now we've got it into something that's a little bit, more workable for us, a little bit more standard. What am I solving for first? X. How do I do that? Subtract 18x from both sides, but not just anywhere. I'm going to subtract it from the 45x. Okay. And what else? Add 45 to both sides, specifically the 90. Okay, so what is 45 minus 18? 27x. And what is that, 135? 90 plus 45. Okay, what's my last step? Divide by 27 on both sides. What's 135 divided by 27? X equals 5. And you'll notice, got my answer right there. And I would be wrong, right? I would get that wrong on the test because what have I failed to do? I failed to actually answer the question. Okay, so I have to do what? Substitute it in for 3x minus 3. So 3 times 5 minus 3. What's 3 times 5? 15 minus 3. 12. Okay, which we see is this answer right here. Okay. So that's the type of work we need to see on a question like that. Does that make sense? We get that? Okay, so hopefully we're learning something. Can I erase this? Okay. Okay. Again, let me double check here. Yes, we are recording. Okay, so we need to go down to 6. Carlos and Stu start hiking from the same base camp and head in opposite directions. So Carlos is, well, let me show us. Carlos is here. Okay, Stu is here. Okay, Carlos walks 6 miles. Okay, due west, then changes direction and walks 5 miles to point C. Stu hikes 6 miles due east and then changes direction and walks 5 miles in a given direction to point S. We will use the diagram to find which hiker is further away from the base camp. Okay? Does anybody know? Who's furthest away? Carlos? You're correct. Yes, Carlos is further away. Can anybody tell me why? Because the angle measure of 140 is greater than 130. What does that cause CB to be? Causes it to be longer than SB, right? Okay, so he is further away because if I have two triangles that have two of the same side lengths, but the interior angle is greater, then that third side is going to be longer. Does that make sense? Okay, so just simply, 140 is greater than 130. Carlos is further away than Stu. Anything along those lines to show me your understanding. So Carlos is further from the base camp. Okay, do we understand that now? And we actually use that principle in a later question. Okay, 4. In fact, we'll end up using it for 7, which I see later on. Okay, for these triangles, select the triangle congruent statement and the postulate or theorem that supports it. Okay, here you have to be fairly careful because there's some things that look similar but are not. Okay, notice how they all start with ABC, 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 correct? Okay, so if I've got A, B, C, then it matters what corresponds to A. See how I have A here? What corresponds to A over here? J. Okay, so J. I got B. What corresponds to B? K. Okay, then obviously L corresponds to C, correct? And here's the reason I say you need to be careful, because there's one here and there's one here, right? Okay, so which JKL do we want? Do we want hypotenuse leg or do we want side angle side? I'm guessing that several of us got it wrong because we chose side angle side, right? Okay, but we don't have side angle side. If I was going to have side angle side, I would need this and this. This is side angle side. Okay, what you're giving up here is not side angle side. Okay, notice that they give me two right triangles, which means I have a different set of congruency statements that I can work with. Notice how I have a hypotenuse BC, a hypotenuse KL, and a leg AC congruent to a leg LJ. So that should tell me, because one, I don't have side angle side to work with, but I do have hypotenuse leg. Does that make any more sense to us now than it did before? Okay. All right. Let's see, number 9. Okay. Use the diagram from the following problems. Let's see, so it's really just number 9. What is the order of angle Q, R, and S from least to greatest. So Q, R, S, least to greatest. Okay? Now, this is what you need to understand. The longer the side, the larger the angle that's opposite of it. The smaller the side, the smaller the angle that's opposite of it. Okay? So what we want to do here is we want to find out what the total length of this side is. So if half of it is 7.7, then the whole length is what? What's 7.7 times 2? 15.4. Okay? And this side, what is, if half of it is 5.7, then what's the whole length? 11.4. Okay? And this side, we already know, is 14.4. So notice it says order these from least to greatest. So what angle is opposite the shortest side? Well, what is the shortest side? What's the shortest side? RS. See, when we talk about a side, we always need a beginning point and an end point to reference a side. What angle is opposite of RS? Angle Q. Okay, so we see, right, that angle is opposite of angle Q. So angle Q is the least. Okay, what's the next longest angle? Or sorry, side. What's QS? Okay, QS. What angle is opposite of QS? Angle, somebody else. Chase, what angle is opposite of QS? See how we have QS here? What angle is opposite to that? Yeah, angle R. Okay? Go opposite. An opposite angle will never share a letter with the side. So notice how, it's side QS. So it's going to be the letter of the angle that doesn't have a Q or an S. Does that make sense? Okay, in the same way with sides to angles. Okay, now the longest side is QR, is QR, correct? What angle is opposite of QR, Nevaeh? S. Okay, so we should get angle Q, or angles Q, R, and S go from least to greatest. Does that make sense? Okay. So it's a matter of looking at opposites. And it works vice versa too. The larger the angle, the longer the side opposite of that angle. Okay? The smaller the angle, the shorter the side that's opposite of it. Okay, so they could have given you all three angle measures and asked you to order the sides from least to greatest, and you could have figured that out too. Questions? Okay, 14. Find a measure of each exterior angle of a regular pentagon. Okay, so this one is pretty easy. I think easier than what you guys are making it out to be. Granted, it's not obviously the most missed question, but hopefully, now granted, what I'm drawing here is not I haven't drawn it to scale, obviously. But when we're talking about exterior angles, we're talking about something that's going to look like these green angles. Okay? Do you understand maybe a little bit more now about what an exterior angle is? Okay? So if it's a regular pentagon, that means that all of these angles should be the same size. Okay? Now, anytime I'm going all the way around a figure, how many degrees am I going? It's the same with no matter what size. Go ahead. 360. So I'm going 300. If I start here and start walking and I come back to this point, I've gone 360 degrees, even though I wasn't going around a circle. Okay? Do you understand so far? Okay, so all I really have to do, anytime they say find the exterior angle measure of one angle of a regular figure, is just take 360 and divide it by the number of angles I'm working with. How many angles do I have? 5. So what's 360 divided by 5? 72. Okay? My hope is that the visual helps you understand why that works the way that it does. Are there any questions there? Okay? So make sure you're making notes for yourself, right? You've got these questions down. Okay? Draw whatever pictures you need to draw to help you remember some of these things. Okay? Don't just count on watching a video later, because unfortunately, too many of you will watch the video, but you won't listen to it. Okay? Does anybody still need this, or can I erase it? Okay. All right, so let's see, 18. Okay, so 18 is drawing from our picture up here. It says if angle 1 and angle 2, oh, okay, nope, never mind. If angle 1 and angle 2 are vertical angles, then what is measure angle 1? What do I know about vertical angles? Vertical angles are what? Congruent. Okay, vertical angles are congruent. You need to write that down if you do not know it by heart. Vertical angles are congruent. Okay, what does that mean I can do with these values? Set them equal to each other. 2x plus 16 is equal to 5x minus 35. Okay? This works because they're vertical angles. You cannot go into questions on a test and just assume, well, I'm going to just set these equal to each other and solve. That doesn't work all the time. Okay? The reason that we knew to do that was because we knew that they were vertical angles. Okay? So don't just work under the assumption that, here I have two things. Let's just set them equal to each other and solve. Okay? We want to use a little bit more than that. Now, once we have them set equal to each other, it shouldn't be terribly difficult. But notice what the question actually wants me to end up with. What does it want in the end? The measure of angle 1. What am I getting out of this? What am I going to end up with? I'm going to end up with a value for x. The value for x is not the measure of angle 1, so be careful. Okay? All right, so what do I need to do first? Subtract 2x from both sides. Okay, and what? Maybe add 35 to both sides. Okay, 16 and 35 is what, like 51? 51 equals 3x. Okay, now what? Divide by 2, very good. Get x equals probably 17. But I'm not done. We've seen this question before, haven't we? Hasn't this been on tests before? And a lot of times, okay, big time answer, stop right there. Okay, go ahead and get your 17 and move on with your day, except it's wrong. Okay, 2 times 17 plus 16, right? Plug it back in. 2 times 17 plus 16. What does that come out to? We got what? 34 plus 16? 50. Okay, 50. Okay. So yes, I understand that, hey, if this question shows up on this test, you will have seen it before, but my hope is that we're picking up on some things every single time when we're learning and we're growing. Okay. Let's see, 18, we need to go back up to 3. Okay. Find the area of a sector. Give your answer in terms of pi. So first, before we can find the area of a sector, we need to know what formula we're going to use. Does anybody know? Pi r squared. why pi r squared and why not 2 pi r? Because we're finding area, so we're going to use the area of a circle formula, but we don't want the entire area of the circle. We want a fraction of it, which is why we use measure in degrees over 360 degrees, okay, because that's our fraction. Okay, we want this in terms of pi, so that means that I'm not actually going to use pi or 3.14. Okay, but what is my radius here? 4, so I can substitute that in. So I got 4 squared. What is the measure of our sector? 54 degrees over 360. Okay, 4 squared is 16. 360 reduce. I think I could reduce both of those by 2 and get maybe what, 27 over 180, right? 27 over 180 would reduce because both those numbers are divisible by 3. 27 divided by 3 is what, 9? 9, and then 180 divided by 3 is what, 60? Yeah, so 9 over 60, both those numbers will reduce by 3, right? 9 divided by 3 is 3. 60 divided by 3 is 20, right? So I'd get what, 3/20ths? Okay, so we have 16 times 3 divided by 20, and I don't know if that reduces or not. At this point, I would probably just use my calculator. Let's see which I have got to pull up. Give me a second here. Okay, so 16 times 3 divided by 20 because it wants it as a decimal anyway. I get 2.4. Notice that we didn't use pi. 2.4 pi centimeters squared. Okay, does that help us out at all? You got to work with those formulas. Okay, write them down, put them on cue cards. I don't know what you guys do to study, but I'd go through my notes, I'd put formulas on cue cards, put the formula on one side, put the title for the formula on the other side, and continually work with that to remind myself, okay, if it asks for area of a sector, I know it's pi r squared, measure over 360, flip it over, okay, got it right, move on. Okay, try that with arc length, try that with several different formulas, right? A lot of success is just knowing how to study. Okay, 7. 7 is one that I really expected would be at the top of the list. So we either guessed right or you guys did better than I assumed. All right, they tell me that measure angle ADC, which is this angle, is greater than measure angle BDC. Okay, so let's give this a double line and say I know that ADC is greater than BDC. Okay, now notice something here, that this line is equal to this line on this triangle, and these two lines, this line right here is shared, so we know that these two triangles have two sides that are the same length. Does that make sense? Okay, so they tell me that AC is 3x plus 32 and BC is 7x plus 16. Find the range of values for x. Now let me ask you, which is bigger, AC or BC? What's that? AC? Yes. Do you know why? Because the angle is greater, right? So if I have two sides of a triangle that are equal to two sides of another triangle, but their interior angles are different, then that third side is going to be different. Does that make sense? So we can write an inequality, 3x plus 32 and 7x plus 16. Okay, what's the inequality symbol? 3x plus 32 is greater than 7x plus 16. So this is going to give me half of our inequality that we want. Okay, can we reduce this down? Ashlyn, how would you go about solving that? Perfect. Subtract 3x. Okay. Maybe, what, subtract 16? Okay, subtract 16 from both sides. Okay, so what's 32 minus 16? So 16 is greater than what? 4x. Can that reduce? Yeah, divide by 4 on both sides. So 4 is greater than x, or x is less than 4. And we have that here, 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 but not there, right? Okay, that one says x is greater than 4. So I know right off the bat that there's more to this. Does that make sense? Okay, the question is, what more is there to it? Okay, here's the really tricky part. Okay, we do not know how big this triangle is or how small it is. Okay, but length has to be greater than what? Any length has to be greater than what? No? I mean, let's talk about anything. If we're talking about the length of something, it has to be greater than what? 0. It has to be greater than 0. And we already know that AC is greater than BC, so we need to start with the smallest side. Okay? So what we want to say is that BC has to be greater than what? 0. We're going to substitute in 7x plus 16 is greater than 0. Now my guess is, because you guys aren't thinking about that we might have gotten this right purely out of luck. How many of you knew to do this? Anybody? How did you guys get negative 16/7 then? Anybody? How did you get negative 16/7? Some of you said that you got this question right. Okay, I'll move on. All right, so what do I do here to solve for x? Subtract 16. Okay, so I've got 7x is greater than negative 16. Now what? Divide by 7, divide by 7. X is greater than negative 16/7. Okay, and that's how we get this. Does that make any more sense than it made before? That the shortest side, whatever it is, has to be greater than 0. And as far as we know, BC is our shortest side. Okay? All right, 12 and 20. Okay, we've seen this question before, I think, on earlier tests. The pilot uses triangles to find the angle of elevation, which is A, angle A, right here. From the ground to the plane, how can she find angle A? Well, notice that this length and this length are the same length, correct? Notice that this length and this length are the same length, correct? Okay, is there anything else that we know for sure that they have that is equal? What's that? 40 degrees? We don't know that yet, though. But there is something that we do know is equal in these two triangles. Does anybody know? Can anybody tell me what angles in that illustration there are equal to each other? And how do we know? 2 and 4 are equal to each other. How do you know? Because they're vertical. Okay, what other angles are equal to each other? 1 and 3, how do you know? Because they're vertical. Are there any vertical angles here? What? Where O is, but let's be more specific, because whenever we deal with like a cross section like that, we have to use 3 letters, right? So I know exactly what angle you're talking about. AOB, correct. Those angles are equal to each other because they're vertical angles, right? You know, like, do you understand now why I put so much emphasis on vertical angles? Because if we can't think that way and can't see it, then we can't use it, okay? Now, how do I know that these two triangles are congruent? Is there any congruency theorem or postulate that I can use to say this triangle is congruent to this triangle? Side angle side, absolutely. So ABO, okay, we've got just one here that says side angle side, right? So if these two triangles are congruent, then their corresponding parts are congruent. And a corresponding angle to angle C is angle A. So by CPCTC, corresponding parts of congruent triangles, so angle A has to equal angle C, so it equals 40 by substitution, because if angle A equals angle C, then I can substitute 40 degrees for angle C, okay? Therefore, I see A as an answer. Does that make sense? We have to be able to see vertical angles. We have to be able to work with them and know that they're there. Any questions or comments on that? Okay. Okay, 20. Okay, find the area of the composite figure. What is this figure made up of in terms of individual parts? A rectangle and two triangles. How do you find the area of a rectangle? Okay, rectangle is length times width. How do you find the area of a triangle? Okay, base times height divided by 2. Okay, and we have what looks to me like two identical triangles. So we can effectively, multiply that by 2 and add those two things, right? So now I've created a formula. All right, what is the length of the rectangle? 18. What is the width? 12. Okay, what is the base of the triangles? 18. What is the height? Okay. So I've got a formula that I can work with. 18 times 12 plus 18 times 9 divided by 2 times 2. Does anybody know what would happen with those two 2's? They can actually cancel each other out. And so actually all I really need is 18 times 12 plus 18 times 9. But if you want to divide by 2 and then multiply by 2, you can sure do that. What is the answer that you come up with? 378. Okay. All right. Those were the most missed questions on your review in this class. Are there questions that are on that we didn't go over that you would like to see worked out because you don't understand them? Did we gain anything from this? Did we learn anything? Okay, hopefully something that we can use. All right, so the remaining 15 minutes, I've got over here, I've got your actual test somewhere. Okay. Okay, so the first question on our test is going to deal with centroids. You guys have worked with centroids before. Centroid is based upon a triangle that has 3 midpoints or mid-segment, well, something like this. Okay, do we see these 3 midpoints? Hopefully. Okay, so if I use those midpoints and I draw them back to their respective vertices, okay, I end up with what are called mid-segments. Okay, or sorry, not mid-segments, but medians. Okay, so these 3 points are medians. Okay? This point right here is what we call a centroid. It's where three medians cross. Okay? Now, they're going to tell you, let's see, let's label this X, Y, and Z. Let's say that and let's call this A. Okay? They're going to tell you something along the lines of, let's say, YA equals, let's say 30. YA equals 30. Okay? Let's see. They might tell you that, oh, hold on, and I haven't labeled some of these other parts. Let's call this H, I, and J. Okay? They'll tell you something along the lines of XI. They might say that that equals, oh, let's try, say that that equals 33. Okay? What they're going to want you to find is XA. Find XA. Now, they give you one piece of information that's helpful and one piece that's a distraction. Does anybody know what piece up there is a distraction? XI? No? It'd be YA. Because, all right, they tell me what XI is. XI is the whole length. I'm looking for XA. Okay? So YA is not helpful. Okay? Now, when we're talking about centroids, does anybody remember what the ratios are to a centroid? 2/3. So basically would be saying that XA, does anybody know, like XA is what of XI? What ratio? 2/3. The length from here to here, the length from the centroid to the vertex is 2/3 of the total length. Now, if they said what, if I ask you what is the ratio from the center to the side, what is the ratio of the center to the side to the whole length? 1/3. Okay? Can I transfer this into like a mathematical equation? XA is 2/3 of XI. Two-thirds times. Okay, let's pause for a second. Let's write XA as just a variable. What does the word is in math? Equals. Okay. Then I got 2/3. What is the word of in math? Multiply. And then XI. Well, do I already know what XI is? What is it? 33. So if I want to know what X is, or XA, what do I have to do? What's 33 times 2/3? 33 times 2 is 66, right? What's 66 divided by 3? Going to be 22. So XA should equal 22. Hold on. I want to make sure. Yeah, because 1/3 of 33 would be 11, right? So 22 plus 11 would be 33. I'd get my whole length that way. Does that make sense? Okay. So when they start talking about centroids and finding individual lengths, you want to think in terms of 2/3 and 1/3 depending upon what segment they've given you and what they're looking for. Okay? Yes. Yes. Okay. In this question, they're going to show you a triangle. And it's going to look something like this. And they're going to ask you to find the coordinates of the centroid. They're not going to say centroid, but that's effectively what they're going to ask you for. Okay? So we'll actually come up with some points that are reasonable, and I'll show you how we can find this no matter what the triangle is. What would be a reasonable set of coordinates for that position right there? 2, -2, 0, right? Okay. What about over here? If that's -2, then that's maybe, what, 4? And it would be up about how much? You want to say 3? Okay. All right. So what would be the x value of this position here approximately? The x value. How far to the right is this position? 2. About how up? I mean, if we're saying that this one here is 3, then this one is probably 7. Okay. Okay. That's fine. That's fine. Okay. So normally what I would tell you you need to do in order to find a centroid is find the midpoint of each of these and then draw those lines back and then find out what the coordinate is here. Okay? But there's a much, 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 much easier way. Okay? The easier way is this, is that you take your x values and you find the average. So -2 plus 2 plus 4 divided by 3. Okay, well, my 2's cancel out, right? And so I'm left with an x coordinate of 4/3. Okay? Okay, and my y coordinates would be 0 plus 7 plus 3 divided by 3. So that'd be 10/3. Okay? And you could change those over to decimals. This would be 1 1/3, which doesn't that look about right? It's a little over 1, but maybe not quite 2. 10/3 is, what is that, 3 1/3? Doesn't that look like it would be about 3 1/3 up? Okay, so that's the easiest way to find the coordinates of the centroid is add your x values, add all 3 of your x values up, divide by 3. That's going to give you the x value of your centroid. Add up all of your y values, divide by 3. And that's going to give you the y value of your centroid. Does that make sense? Okay, that is the easiest way. That is not in your book. Okay? So, something new for you. Let's see. I think I've got it. The bell's going to ring. We're going to stop here, okay, with this question.